Okay, welcome to Foundations of Programming and Data Structures. In this very first lecture, we will talk about the key ideas in computer science, and which is problem solving using computing systems. So we will be mainly talking about these two key ideas: what's a problem solving and what's a computing system at the very high levels. Okay, so the problem solving is defined as like a generic or ad hoc methods that can be used in an orderly manner to find a solution to a problem. This could be a math problem or any other types of problems, right? In CS, when we talk about problem solving, depending on whatever the problem you have, we are interested in developing what's known as the algorithms and some data structures that allows us to process our data or the information. Okay, so the very first thing is algorithms, which simply means finding out the necessary steps to perform a given task or perform the steps so that you can get the solution. So for example, here there's a problem to find some numbers, and this has been found out by somebody and listed here as do this, do this, do this type of things. Okay, so the step-by-step refinement of the task is known as an algorithm design or algorithm development, and this is one of the key things we will be learning in this course. The other thing is you also need to, depending on the problem, you need to identify how can you represent your data or organize your data in the computing system so that we can process it, we can change it, we can modify. So these are the two important things in developing programs. And that's the most important and the crucial step of problem solving in computer science. Once you do this, and as you see so far, we did not talk about it in the programming languages. So when you talk about when you are able to perform these things, then the rest is really easy. All you have to just learn one language and be able to code these solutions or these data structures using that specific language. In this case, we will be using the C language because this will be used in some other courses as well, but several other languages have the same capabilities, and there should be no difficulty in learning a new language after you understand these key concepts and the key ideas using C. And I will highly recommend you guys to visit that YouTube channel and learn more about programming and problem solving. This specifically, these videos does not really talk about too much language itself. They just focus more on how to develop solutions, etc. So hopefully, if you have time, please watch as many as you can to improve your problem solving skills using computing systems. Okay. Related to this problem solving, sometimes we get this type of questions as can the computers think, or can they come up with solutions to the problems like in human beings, right? And the answer for this one is, as you can guess, is no. It's you, as the programmer, you develop the solutions, and the computer just simply follows your instructions. And they are good in doing that because they are very fast, they are very accurate, but unfortunately, they cannot come up with the solutions themselves. So it's the programmer's or the algorithm designer's job to find out the right set of instructions and steps that needs to be followed by the computers. And how do they play even a chess in that case, right? If they don't think or they don't. So many of these things are coded by somebody, and now the computers are just simply following their instructions. And of course, there's so many possibilities they can explore. So it makes it easy for computers to look at all the possible cases, and among these cases, it can select the best based on the given instructions and based on the heuristics put into the code by the programmer. Another question sometimes we get, and that is important as well, because for the same problem, can the two different programmers came up with the same solutions? And that depends on the problems. In toy problems that we will be seeing at the beginning of these lectures, most likely most of us will come up with the same solutions because that's simple. But as the problems get complicated, really it's not that easy to come up with the same solutions. But that doesn't mean that you get the wrong answer. It's just different solutions may happen to happen for different for the same problem. And in that case, usually we look at which one is much more efficient, how much time or memory we consume and things like this. So this is an also important concepts, and you will be learning more about how to analyze the algorithms, how to judge whether they're good or bad, depending on the given problem or situation in the analysis of algorithm courses. So here in this course, we will specifically focus more on how to design, how to come up with a solution. Okay, so the next we will be talking about computing systems. Okay, so what's a computing system? Basically, as you can imagine, you have a computer, but we're not just going to interest in that computer. We would like to look at a little bit inside the computer. So the computing systems or the computers includes a computing unit, usually we call it as the CPU, central processing unit, and some internal memory where we can store information. And along with these two key components, we also have many other components, and we can classify all as like input-output devices or peripheral devices. So when you look at the computing system from that perspective, basically you have a CPU in which we have two major units. One is the control unit, one is the arithmetic logic unit, which is doing the computations, additions, multiplications, divisions, and comparisons and things like this, and then the memory. Okay, and these two things are connected to each other through many wires, so the CPU can send and receive information through these lanes to the memory. Okay, and of course we can put the other I/O devices into the picture as well, but at this point, I/O devices are not important for us, so let's just focus on CPU and the internal memory, because understanding that the interaction is very much important to understand some of the key concepts in programming later on as well, and understand how the programs work basically. So that's why it's important for us. And here the key idea in these modern architectures or modern computers, you have these two components, a CPU and a memory. And the CPU is an electronic device which can perform so many tasks, but all these tasks or the instructions are not stored as part of the CPU. It needs to get that instruction from somewhere. So where are these instructions? So actually the instructions are now stored in the main memory. But when I'm getting instructions, when I'm doing something, I need to also process some data, right? Like some integers, some characters I need to read, modify, and all that data is stored here as well. So now the data and the instructions are stored in the main memory, and then how the CPU knows which instructions to run, etc. So the CPU in the control unit has a special register that we call, which is called the program counter, which knows what's the address of the next instruction. It knows that I need to run that instruction, right? So it goes and gets that instruction and executes it, and then it increments that program counter by 1, so it can go and get the next instruction, next instructions, next. So that's the life cycle of any programs. Okay, so the CPU designed in a way that it's an electronic device with a clock that's kicking many times per second. At every clock kick, it goes and gets one instruction and executes it depending on the length of that instruction. And this architecture is known as von Neumann architecture, and it might be a good idea to know what that person did, and basically came up with that idea that designed the CPU or the processing unit in a much more general sense, and then they store the instructions in the memory. So now you can store any types of instructions in the memory, and the CPU will be able to perform those things. This is in contrast of like some specific electronic devices that are designed to perform certain specific tasks, right? So you cannot use them for general purpose. But that makes us to create a general purpose computing unit, and this can be programmed by putting all the necessary instructions in the main memory. So now this device can do many things depending on what instructions you put into the main memory. Okay, I'll stop here, and next time I'll talk about how the information is stored in memory. Okay.